Hello. In this video, we will look at the genetic algorithm sequencer from my book, Sound of Music Projects for Eurorack and Beyond. This to me is another fun project to build on a breadboard. Just requires a few components, a couple of switches or momentary switches, as these particular ones are. These work well on a breadboard. A basic Teensy, in this case I'm using the LC, but a Teensy 4 or any of the other variants would work well. I also have a rotary encoder that I've set up to control the tempo. In terms of the switches, the first one toggles the play mode, so play on and off. The next one has to do with ignoring the rhythms from if you're using external sync with MIDI clock. The next one is a selection for either internal or external clock. And then finally, we have a record button. And with this, you can press the button and record a sequence of notes that becomes essentially the DNA for the genetic algorithm. So that's a lot of fun. And in terms of the source code, of course, I talk about this in the chapter in the book, but one of the things I would really stress is that this project is not meant to be an end of the exploration, but rather a framework to begin your exploration. And so the way that I have it configured, it's really the output is, we might describe as stochastic. There's definitely a random element to it. And depending on your tastes, you could stick closer to home with that original DNA, perhaps take some of the functions that are called that give it a somewhat of a similar quality or flavor to the output, and have more variants, or perhaps stick closer to the original DNA. Just also especially taking a look at that fitness function. What is it that you would like your algorithm to do in terms of evaluating what constitutes a good or a not so good in terms of the musicality of it. And it's just vast, the directions you could go with that. So as I describe in the book, there are C++ classes that encapsulate a lot of the more challenging parts of the genetic algorithm, the biological process, and really provide a framework so that you can focus your attention on those functions of interest, and particularly the fitness function. So in any case, let's take a listen, and we'll look at my configuration here on the computer. I'm using Ableton Live just to get MIDI to and from the device. And of course, this project could work well with, for example, the MIDI to control voltage concepts from that chapter. You could make a genetic control voltage converter, which I think would be pretty cool. But today, just for convenience, we will be running the output, the MIDI output, into Ableton. So in this case, I've got an Arturia MIDI controller that's providing output to the Teensy controller. Then the Teensy is doing its thing and sending MIDI back to this audio synthesizer, this software synthesizer on this track. And then in case you want to try with the drum groove, I do have a loop set up on this channel. So that's how things are configured. We should probably take a quick look at the preferences in Ableton, and you'll want to make sure that you're sending sync to the Teensy if you do in fact want it to be able to match and follow the MIDI clock in that way. And of course, generally making that Teensy controller available to Ableton. And then also a quick look over in the Arduino IDE. You want to make sure that you have your board selected, you know what port it's on, and important to select MIDI as the type. And so when you upload your code, this is pretty cool, that Teensy device becomes an autonomous MIDI controller at that point, that you can use with really any DAW, and that I think is rather cool. Well, let's take a listen to it, and I will start by putting my headphones on. I'll press the record button to record some notes into the DNA of the sequencer Okay, I've just recorded a simple scale. I'll turn the recording off, and now let's check our settings for internal or external. So let's start with internal clock. Now when I press play, we should hear the genetic algorithms at work. Let's change the tempo. So you can start to hear some of those interesting sort of organic variations that are coming from the algorithm. Let's go ahead and switch over to internal clock now, and scroll this down so we can see. Yeah, so now we're on external clock, and if we play Ableton, we should hear that same sequential data, but in sync with the clock of the DAW. So there you have it, a genetic sequencer. Quite a fun project. There's quite a bit in terms of the internals, learning how to do that, a lot of reading about biological processes and so on. But through the wonders of C++ classes, much of the hard stuff is encapsulated in an easy to use class. And then you can again use those specific functions like the fitness function and begin to craft your own approach to a genetic algorithm. So I hope you found this video to be interesting, and I hope that you are enjoying to explore these concepts as a part of your own musical output.